or whether you're going to get your homework as you go out. All right, so this is lesson 4.3. Even though we're not doing a book assignment, guys, I still put the lesson number with it. So if as you're working through this, if you can't remember what I said or what was going on, there are some more examples in the book. Standard form is ax plus by equals c. You guys have this already written down. What standard form is, ladies and gentlemen, is x and y are on the same side of the equation. We've already had a lot of that because you had to solve for y. What we're going to do now is to give you a method for graphing where you don't have to make it y equals mx plus b. So I'm going to use x and y intercepts when I have x and y on the same side of the equation. X-intercept, quick definition, that's an H, where a line crosses the x-axis. All right, and I don't know, I need to look at what you guys have. I don't have it in front of me. Is there a definition already there, guys? All right, you may have to write that in. It does say x and y intercepts off to the side, so you could add this in. You may not need to. How many of you already know what x and y intercepts are? All right, if you already know what that definition is that something you have to write down, guys? Not necessarily. Y-intercept, we should already know. Why? Because we've been graphing with the y-intercept, haven't we, guys? The y-intercept is just where a line crosses the y-axis. Exactly. It's pretty self-explanatory. But what's important, the reason I start with that, ladies and gentlemen, is there's things about the x and y-axis that are going to help us solve these equations. They're going to help us find these intercepts rather quickly. All right? So you guys should have some graphs. Am I correct?
Yes.
But I think yours looks a little bit different. Does this one match?
Yes.
Yes.
Okay. This one does not match. So
It's the other way.
it's the other way. Ah, all right. So let's draw this one in. Let's use the red graph, guys. Sorry. So at your Z, I want you to write in the x and y intercept. That one is, so that's why I drew it closer to the 3 there on the x-axis. I know. Awesome. I said, I know. I need you guys to move it over to the 3. I do my best I can with clip art in these graphs. This is the best I can do, and sometimes things get shifted a little bit. As you can see, sometimes things, when we copy and paste them, even get moved around even more. All right? So, when we say name the x and y intercepts, ladies and gentlemen, what I want you to keep in mind here, and this is what I had to remind second hour, is we want them written as ordered pairs. So I had a lot of people who did this. They said the x-intercept was -3. How many people wrote that for the first one? X-intercept is -3. Beautiful. Can you write that as an ordered pair?
Yeah.
Okay, so if I'm going to write it as an ordered pair, I need an x and then I need a y. What's the y value on that x-axis? Cassidy's doing this. I don't think it means okay. What is she telling us? 0. That is the y. That's what you were telling me, right? It was 0, right? Okay.
No, okay.
I thought you were saying
No, I think she was saying she was doing it just like this. I wasn't supposed to. Yeah. Okay, this is better.
I think she said 3.
No, she did not. What's the y-intercept? How many people wrote 3 down for the y-intercept? But I can't write 3 comma. Where's my comma going to have to go this time?
Front.
In front, because what's my x value on the y-axis?
0.
0. Beautiful. Yeah, they're not too hard, are they?
Yes. So far.
All right. How many people had an x-intercept here of +3?
Yeah.
And then comma 0. And then what was my y-intercept on this new red line? 0. And then -3.
Bang, bang.
All right. What do the x-intercepts have in common?
They both are.
They both are the same. They both have 0. Specifically where, Rosemary?
Oh, yeah, they are.
Or in that.
No, just the x-intercepts. Look at just your x-intercepts.
They're actually the same.
Oh, they're not exactly the same.
Oh, it's
Josh.
actually.
Good job. The y value is 0. Is there any x-intercept, ladies and gentlemen, that's not going to have y equal to 0? No, because everywhere on that x-axis, the y value is 0. So now, obviously, what do these y values have in common? The x value is 0. All right. Is the x value always going to be 0 on that y-axis?
Yeah.
Oh, yes.
Yeah, the y value is going to change, right?
Uh-huh.
But this x value here is always going to be 0. So what we're going to do now, ladies and gentlemen, is use those characteristics of x and y intercepts to help us find them and then to graph them. So let's take a look at the next part. All right, they're going to give you information like this. Find the, given the x-intercepts, draw the graph. So we have an x-intercept of 2, so I'm going to go to my x-axis. We know that it's the point 2, 0. So I'm going to graph the point 2, 0. I know my y-intercept is 4, so that means it is 0, 4. So I'm going to graph 0, 4. I'm going to connect those. It's not as accurate of a line as my slope-intercept, is it, guys? My slope-intercept, I can put a bunch of points in there and connect it pretty nicely. But does this give me a quick graph? Does it let me see the direction of the line? Gives me a couple of points on the line. Very nice. How do I graph an x-intercept of -2?
Go -2.
-2 on the x-axis. Beautiful. What do I do with this fraction of 1/3?
You go 1/3 up, you go 1 up, up, 1 up.
You go up 1/3. It's barely off the x-axis, guys.
It's not a slope, someone's saying up one.
Ooh, no. It's up 1/3. You go up 1/3 of a box. It is not your slope. We kind of put that in there to trick you guys.
Thank
You're welcome.
Oh, yeah.
What?
Not a very accurate line because they're so close together, guys. But make sure when we're dealing with x and y intercepts, fractions are not a rise and a run. This is the point 0 and 1/3. All right. Are we good at making graphs?
No.
Yes.
That's like half your assignment. So Austin, good luck.
Wait, can you go back, please?
No.
Please?
No, I'm not going to. I will put it on a split screen.
Thank you.
All right, now we need to find x and y intercepts. So that's why it's important to know this definition. For the x-intercept, y was equal to 0. For the y-intercept, x was equal to 0. So how does that help me? Well, if I need to find the x-intercept, I'm going to plug this 0 in for y. So I'm going to have this little equation. 4x minus 3 times 0 equals -12. Well, what's going to happen to this 3 times 0, guys? It becomes 0. It just disappears. It's pretty worthless, isn't it? So really, I'm left with the equation 4x is equal to -12. Well, can I solve that for x?
Yep.
Yeah. Rachel, how do I undo multiplication? Division. So I'm going to divide by 4.
Wait, what are you going? It's too fast.
Yes.
How do you get the
Slow
0?
down.
Well, it's tough
How did I
one,
get?
no.
How did I get the 0? What do we know about the x-intercept? What is y always going to be? 0. And we knew that from the previous screen, correct? All right. So that's where I'm getting this 0.
It says that y intercepts an x and equals 0.
Well, I have to find. I can only do one at a time.
Yeah, I know.
So my x-intercept now is -3. I'm going to find my y-intercept by making x equal to 0. So notice, guys, I didn't write on top of this equation, did I? No, because I need to use that whole equation a second time. I need to take 0 and plug it in for x. And then minus 3y equals -12. Now I lose this minus.
Wow.
What's going to happen to this 4 times 0?
It's going to cancel.
It's gone. It's kind of useless. 0 in the equation. We can leave it out. It doesn't matter whether I add 0 or subtract 0, it's still going to be negative 12. Am I going to undo that multiplication the same way we did it before?
Yeah.
Divide by negative 3. Make sure you have that negative with it. So you have a y-intercept of 4. 1, 2, 3, 4. We know the x is 0, the y is 4, so that's this point. Connect that. And there's our quick graph. Tyler.
Just because x is the negative, I mean x is 4, and then y is the negative 3. It's already there, but it's in there.
For this problem it is, because it just happens that 4 times 3 is 12, correct? Well, let's go take a look at this. Let's go take a look at this one. I'm going to plug in, I'm going to find my x-intercept by making y is equal to 0. Austin, are you done with this other screen? Can I go to full screen? All right. Beth, you got a question or a comment? Back out, I'm sure.
That.
So it's always gonna, if you're always gonna like do it times 0, could you just like take it out of the problem?
Ladies and gentlemen, Becca just asked, if I'm always going to multiply by 0, could I just ignore this and just write 3x equals 6?
Yes.
Yeah, you could. Why would I model this? Yes, because I love you doing work. So that people understand why I'm dropping out each term, correct? I'm dropping it out because it was a 0. For the second one, if we said for the y-intercept, x is equal to 0, we're basically dropping out this term, but you have to have the negative y. That's the only thing that makes me nervous there, is if we don't I've gotten a lot more compliments from my freshmen today than I have from anyone else. If we forget this. This is Mr. Hoffman. This is his jersey. He is the big meanie winner. All right. Now, you can't just drop it out and not finish it, ladies and gentlemen. You do have to divide by 3 and get x is equal to 2.
What?
And so we have an x-intercept of 2. Here, what do I do with this?
Oh, you have to divide that by what?
Negative 1. Good job. Armando's on fire on Monday. It's a new market day, a new Armando.
He doesn't know that.
Yeah, you gotta keep that straight though.
That's so easy. Yeah, he did something so great.
All right.
Of course
Ladies
he could've
and gentlemen. Tim, should I send the page for you? Does that help?
Yeah.
All right. Ladies and gentlemen, what are the next 2 problems?
Right there, right on the bottom of the sheet.
On your own. Get those done, bring them to Mr. Clemmerai, and then you can get a worksheet and start on your homework.
What is Keel Windrow?
He's the one who's making me wear this